Okay, so for today's lesson, it's mainly revision. So Unit 31 is typical reactions of selected functional groups. So we're going to discuss reactions related to alkanes, alkenes, which we have learned in Unit 27. And then we move on to talk about reactions related to haloalkanes, alcohols, aldehydes, ketones, and carboxylic acid and esters. So today we only focus on the first two, okay? I will try to finish the revision for reaction of these two groups of organic compounds. So let's begin with page 2. So just a quick revision how we name those functional groups. Okay, so alkane, there's no functional group. For alkene, what is a functional group? Do you still remember? Right, so the way we write it is the CC double bond, and the way we call it is just carbon-carbon double bond. That's how we call the functional group. Okay, and then the next group we have alcohol. Okay, so for alcohol, the functional group is the OH group. So how do we name those OH group? Okay, so for OH group, we'll name it as hydroxyl group or hydroxy group. We don't call it alcohol group, okay? So pay attention to that one. And then from here, the next one, we got aldehyde. So aldehyde, we know it has the C double bond to O, and this C double bond to O must be at the end of the carbon chain, okay? So you need to have or write out this hydrogen to state that it's at the end of the carbon chain. Okay, and for this functional group, we call it the aldehyde group. Okay, so you can guess the next one. The next one we have ketone, and then the name for that functional group, we just call it ketone group. And for ketone, okay, we write the C double bond O, and it should be at the middle of the carbon chain. Okay. And then the next one we have the carboxylic acid. Okay, so for this one, the functional group we write C double bond O, and then we have OH. That's a functional group, and how do we call it? Okay, it's not carboxylic group. We call it carboxyl group. Okay, so it's a little bit similar to the hydroxyl group for alcohol. Okay, so we change the name a little bit because of the OH. And then the last one is the ester. So for ester, remember the functional group is like this. Okay, and we just call it ester group. Okay, so that's a quick revision of all the functional groups and we have learned before. And remember, we have mentioned we have the name for C double bond O. We call that carbonyl group. Okay, so as you can see, from aldehyde to ester, so these four, for the functional group, they all contain the carbonyl group. Okay. The carbonyl group referred to C double bond O. So for these four, they have the carbonyl group. Okay, so far any question? Stay with me. Hello? Okay, good. Okay, so in this unit, while we're going through all kinds of reactions related to different groups, so the things that you are required to remember are the reagents involved, and then the second is the conditions required for those reactions. For example, does it need a catalyst, or can it take place under room temperature? What kind of solvent is involved? Is it in organosolvent or just water as aqueous solution to start the reaction? Okay, and third, you need to consider the product that it formed. Remember, in Unit 27, we have discussed sometimes it may form a major product and with a minor product because the different stability of the carbocation. Okay, so you need to be able to work out the both of the products and work out which one going to be the major product and also state the reason. And lastly, you're going to be expect to state the observations. So for example, any color change, okay, that's the most significant observations you may think of. So for every reaction, remember we need to go through all 4 points, okay? So let's move on to the first type. We have alkanes. Again, we have learned most of the reactions in Unit 27, so it would just be a quick recap. So for the first type, the most common one, when we talk about alkanes, we would talk about the combustion of alkane to generate energy. Okay, so remember, if the carbon chain is between 1 to 5, okay, only have 1 or 1 to 5 carbons in the carbon chain, then it would burn with a non-luminous flame. It will be a clean flame, so it will undergo complete combustion. But if the carbon chain got more than 5 carbons in it, then it would burn with incomplete combustion. So you will see the flame become orange and it will produce some soot after combustion. So we describe that as sooty orange flame. Okay, and for incomplete combustion, the possible product may be carbon monoxide or carbon. Okay, so carbon, that's a soot it produced. And for this one, try to work out or try to balance the equation. So how can we do that? Let's take the first one as an example and do it together. So if we start from the left-hand side, the molecule we have here is a hexane. Okay, so when we burn hexane completely, then we expect it to form carbon dioxide and water. So on the left-hand side, we got 6 carbon. So if we try to balance it, we may put a 6 here. And then on the left-hand side, 14 hydrogen. So on the right-hand side, we may give a coefficient for water 7. Okay. And then now let's count how many oxygen we have on the right-hand side. 12 plus 7, so total 19. So here that will be 19 over 2. Okay, because it's O2, oxygen gas. And remember, normally we don't want to see fractions in the equation, so we need to multiply by 2 and give a whole number coefficient for your equation. Then it becomes 2, 19, 12, and 14. Okay, so that's how you balance the equation. And then you can try to balance the rest too using the same method. Remember, we want the whole number coefficient. Okay, so we do double them. So the second one will be 2, 13, 12, 14. And the last one will be 2, 7, 12, 14. Okay, and you can see that when we have incomplete combustion, it reacts with less oxygen. Okay, because it cannot have enough oxygen, so it will only produce carbon monoxide or just soot. Okay, so that's for the first part, combustion. All good? Okay, this part no problem. Okay, then next one. Next one, remember we have gone through these mechanisms, and it's called free radical substitution with halogens. And for this one, of course, we need to have alkane to react with chlorine, bromine, or iodine. Okay, and we need the UV light or the sunlight to start the reaction. Okay, and then it will undergo the free radical substitution mechanism to produce a product. And remember, the product would be in a mixture. So it would first substitute one of the hydrogen. And then if we have more chlorine in it, then it will substitute the other hydrogen in it. So the formula becomes CH2CO2. Okay, if again there's excess of chlorine in it, it will further substitute the hydrogen in the alkane. And lastly, if we have enough or plenty of or in excess of chlorine, then it will be able to substitute all hydrogens in the alkane. Okay, and for this example, what's the expected observation for it? So at the beginning, we have chlorine, okay, and when it dissolves, at the beginning we have the chlorine. Do you remember the chlorine gas color? I think when we did the experiment, we used the solution, okay? So similar, okay, similar color. So for chlorine gas, it's a yellowish green gas. Okay, because it's used to substitute the hydrogen in the methane, so it will become colorless after the reaction. Okay. And remember, the condition is very important. You must state you need UV light or sunlight. Okay, and one of the question that it may ask you, if we want to obtain CH3Cl in the highest yield, so what can we do? How to monitor the amount of the two reactants? Okay, if we only want chlorine to substitute one of the hydrogen, that means we should put only small amount of chlorine gas into it. Okay, so for here, we should put limiting amount of chlorine. Okay, so it would just be enough to substitute one of the hydrogen. Okay, and the reaction should, hopefully it will stop here. So no further reaction would take place. But if we want the reaction to proceed to the last step to obtain the highest yield for CCl4, what can we do? Which reactant we should put limited amount? Which reactant we should put in excess? Okay, so remember the two reactants we have here is methane and chlorine. Okay, and now we want to, yes, okay. So this time, if we want the chlorine to substitute all hydrogen, then we need to have chlorine gas in excess, okay? Or you say put limited amount of the methane. This time we put excess amount. Chlorine gas to make sure that the reaction proceeds to the last step. Okay, replace all the hydrogen. Okay, so that's the second type of reaction related to alkane. Yeah, that's also fine. Okay, you can say you put excess amount of chlorine. You can also say just put limited amount of methane or alkane. Okay, that's fine, no problem. Okay, so pretty easy for alkane groups. Now we move to alkenes. Okay, so here, again, we start with some of the revision of Unit 27. And here I'm going to introduce just a few more reactions related to alkenes. But remember, all the ones that you're going to be assessed is summarized in Unit 27. So later I'm going to point out some of the reactions are going to be assessed in this year, but not in your IFY. Okay, so first one, let's start with the electrophilic addition reaction with hydrogen. Okay, so the reactant we required in this case is the alkene with hydrogen. And also for here, the condition you need to remember, we need a catalyst. And also you need to remember what kind of catalyst we need. So we need platinum or nickel or palladium. Okay, one of the three catalysts. And then after the reaction, okay, the hydrogen would add to the two sides of the double bond and then form the alkane. So for this example, the first example, we're going to add hydrogen onto both sides of the double bond. Then it will form the alkane. Okay, and since we are adding hydrogen, so this process can also be referred as hydrogenation reaction. Okay, so for this reaction, remember to state the condition. You need a catalyst. You can write either platinum or nickel or palladium. Okay, one of the three. So, and you need to write it under the arrow to state the condition. Okay, so that's the first example. And here we are adding, sorry, our alkene is react with a symmetrical reagent. Okay, so hydrogen is H to H, so it's symmetrical. It got only one bond. And then for this one, okay, what's going to be the product? Okay, so again, we are going to add the add the hydrogen onto both sides of the double bond. Yes. Okay. Yes, for your question. So this time, so the product we're gonna have is, again, we have 4 carbons. The carbon chain, then we fill in the rest of the hydrogen. Okay. And although mechanisms are not required in okay, so for here, I will put the stars that you would be required to recall the mechanism, okay, because it's required in your IFY. So if I use the blue to put a star, that means the mechanism is required. Okay, so you still need to remember the free radical substitution. And again, for this one, electrophilic addition, the mechanism is required. So how should you draw this? Okay, maybe I draw the first example here. So if we have hydrogen, hydrogen, remember the double bond, okay, break, and then it will move to here. Maybe zoom in a little bit. Okay, and then it will form the carbocation. And then we also have hydrogen, and then join it. And then it will give us the product. Okay, so that's the first one. And then okay, so remember this bond breaks. This bond represents 2 electrons, and this hydrogen will receive 2 electrons. So the one that's from itself, and also it gained 1 more electron. Okay, so it's negatively charged. Okay, and similarly, with symmetrical substance, it can react with bromine. So for bromine, the one that we have talked about in Unit 27, it's in organic solvent. Okay, so again, a quick revision. So if we have bromine, okay, if we have bromine, the bond gonna break like this. Okay, and then it will form the carbocation and also the bromide. And then remember to draw your arrow from the minus to the positive. Okay, positively charged carbon, and then it will give you the product. Okay, so that's in organic solvent. Okay, no water in it. So you just need to add the bromine onto both sides of the double bond. Okay, so similarly, I believe you can do that for the second one. Okay, so we just need to put our bromine onto it. Left hand side, right hand side. Remember, the rest of the carbon chain doesn't change. Okay, so for this one, do you still remember the observation? If bromine is in organic solvent, what kind of color does it have? Okay, it should be in orange or brown color. Okay, and it was decolorized quickly when shaken with alkene. Okay, very good. Okay, so yellow-brown color will decolorize quickly. Okay, so a quick recap from what you have learned. So this unit, I'm going to introduce something new. Okay, if the bromine is not in organic solvent, but this time it's in water, so the state changed to aqueous solution, then what are we going to have? Okay, so again, maybe I draw the intermediates to show you. So if we react with bromine, okay, so the double bond moved to here and this bond breaks. Again, we form the carbocation. Okay. Okay, so here we got the carbocation. And then remember the next step, we're going to draw the negatively charged ion that moves to here. Remember now we are in aqueous solution, so we got two kinds of negative ion. Okay, so first we have bromide ion, and secondly, because it's in aqueous solution, water would dissociate to form hydrogen ion and hydroxide ion. Okay, so here we also got a choice that we have hydroxide ion. So this hydroxide ion, okay, remember from the negative charge to the positive charge, okay, can go to that side. So it would form a side product, okay, which is here, the bromoalkanol. Okay, that's a side product. So we can write out the two products formed in this reaction. So again, similarly, we will form the dibromoalkane. But this time we also form this. Okay, so it's going to be a mixture of products. Okay, any question for this one? Okay, so similarly, if we draw the mechanism for the second one, we will be able to work out the two products. Okay, again, the same product as the previous one. So you just add bromine onto both side of the double bond. Sorry, I missed one carbon. Whoops. And then we can also have the OH that add on to the carbon. Okay, so it would be a mixture. Okay, so do you remember what's the color of bromine when it dissolves in water? This time, not in organic solvent. Okay, so oh yes, very good. Okay, so it should be in brown color. Okay, so when bromine dissolves in aqueous in water, it will form a brown solution, and after shaken with alkene, it will add on to the double bond. Okay, so the brown color disappear. Okay. Then the next one, and I believe that's the last one I'm going to talk about. No, sorry. The next one. So addition with potassium permanganate solution. Okay, in unit 27, you have learned addition of cold potassium permanganate solution in acidic condition. Okay, and the product, the mechanism, just the same. Okay, but you're gonna see different color change. That's due to the different product formed. Okay, so when it talk about in alkaline condition, that's the part we are going to mention in this unit. Okay, so again, we have the cold potassium permanganate. And to make it into an alkaline condition, we just need to state that it contains OH minus in it. Okay, and the product still the same. We just add OH to the both side of the double bond. Okay, so the product for the organic part stay the same. Okay, but this time when it's in alkaline condition, it will be turned into manganese 4. Okay, it will be changed to manganese 4. Okay, so do you know the color change? What are you going to see? What's the manganese 7? The color for this one, potassium permanganate solutions color. No. At the beginning of the reactant we're putting, what's the color? Do you remember? You have used it before. Purple. Yes, very good. It's in purple. Okay. And do you remember the color for manganese 4 oxide? So this time manganese changed to +4 oxidation state. So from +7 to +4. It's just it undergo redox reaction. So it will after the reaction, okay? After the reaction, okay? That actually I should write this one here. That's a product, okay? After the reaction. Because I want you to remember the color change. Okay, so after reaction, no, it's not colorless. Okay, so for manganese 4, it's brown in color. You can say brown or black. Okay, so I can show you the video of this. Give me a second.
Dials. Dark purple manganate 7 ions are reduced to insoluble brown manganese 4 oxide, which produces a turbid brownish suspension.
Okay, so in the video it tells you that it's I would say a dark brown. Okay, so but you can also write it as a black. Okay, so and for this one, what's going to be the product? Let's fill it in. Okay, and a recap: if we do it in acidic condition, and also that can be a test for the CC double bond, we could do it in acidic condition. And for the acidic condition, okay, I believe you remember the color change. So it will change from the purple to colorless. Okay, so a significant color change will be easier to show whether the CC double bond appears or not. Okay. Okay, so let me see how far are we. We're on step 6. Okay, let's see if we can finish this part. And the next part, okay, again, addition reaction, but this time we are reacting with asymmetrical reagent like HCl, okay, HBr. So for this case, you need to remember we're going to have a mixture of the two substances, okay, if the alkane is asymmetrical. Okay, so take a look at the first part. We have the symmetrical alkene. Okay, this two. So we just add, again, the mechanism is required. So for this one, if you draw the mechanism, okay, because chlorine is more electronegative, okay, and then hydrogen is slightly positively charged, okay, and then the bond will break, it will form the intermediate. H. And then the chloride gonna attack to the positively charged carbon, and then we'll give you the product. Okay, because it's symmetrical, your alkane is symmetrical for this case, so it doesn't really matter which side you draw the carbocation. Okay, so for this one, again, here you will have okay, so you will form this one. Okay, and then the next part, we're going to consider if it's a asymmetrical alkene. Okay, what should we do? Okay, remember the key sentence you are required to memorize for your IFY exam. The hydrogen adds to the side of the double bond with the most hydrogens, okay, to form the most stable carbocation. Okay, and the system is reminding me I'm running out of time, so I have to start a new one, and I'll let you know the number.